Hello viewers. So today uh, we'll discuss one of the application of derivatives, and the topic is tangents and normals. Viewers, the concept of derivatives has a wide applications in different fields of science and technology. Now today we'll discuss one of the applications of uh, differential calculus, that is how to find the tangents and normals to a given curve. So let us start. Suppose y is equal to fx be the equation of a curve. Clear? Now suppose the curve is like this. Suppose we have this is the curve, clear, and this is y is equal to fx. Now let us take this point P and say the coordinates of this point P are x1 comma y1, clear, and these are the coordinate axis, and these are the y-axis and x-axis, clear. So this is the curve, and we have, say, these are the 2 points A and B, clear. Now suppose we draw a tangent to this curve at point P, clear. So let us draw the tangent. Now say this is the tangent, say T is the tangent. Now this tangent, say, makes an angle of theta with the positive direction of x-axis. Now the aim of this discussion is to find the equation of this tangent. So we know that the slope of this tangent is given by m is equal to tan theta, or if we differentiate this function, that is the equation of the curve y equal to fx, and then we substitute this point x1 comma y1, then we'll get the slope of this tangent t at this point P. So we have dy over dx at point x1 comma y1 is the slope, clear. So this is our tangent line. So this is our tangent line, clear. Now from coordinate geometry we know that the equation of a line which passes through a point, say P, x1 comma y1, and having slope m is given by y minus y1 over x minus x1 is equal to m. So this is the point slope form. This is the point slope form, clear. So we have this point x1 comma y1, and we have the slope m at this point x1 comma y1, which is the point P, clear. And dy by dx can be obtained by differentiating the Cartesian equation of the given curve. So here's what we have discussed so far. We have a curve y is equal to fx, and we have a point P on this curve, and we want to find the Cartesian equation of this tangent line at this point P. and which is given by y minus y1 divided by x minus x1 equal to m. So remember this result. Clear? Now viewers, at this point P we have another line, and this line is perpendicular to this tangent. Clear? And this line is known as the normal to the curve. So this line, say n, here the tangent line was t. Clear? So we have this normal at this point P, and say this angle is pi by 2. So this angle is pi by 2. Clear? So our aim is to find the equation of this tangent line, which is given by this equation, and at the same time if we want to find the equation of this normal, then what we will do, the product of the slopes of these two lines, that is the normal and the tangent, must be equal to minus 1. So the slope of normal is minus 1 over m. Clear? Hence the equation of this normal will be given by, I am writing it here, and the equation will be y minus y1 over x minus x1 is equal to minus 1 over m. Clear? So here's one of the application of derivatives is to find the tangents and normals. So here we have a curve, we have the tangents and tangent line and normal line at this point P, and we'll find their equation by utilizing these two equations. So this is equation number 2. Clear? So let us take some examples to explain the concept of tangent and normals. Clear? Viewers, I am taking a very simple problem, but it is a very conceptual problem. Find the equation of the tangent to the curve y equal to sine x at x is equal to pi by 2. Now viewers, we know that the graph of sine x is here we have minus 1 and here we have plus 1. So we know that the graph of sine x is like this. Okay, this is like this, and here we also have like this. Clear? So this point is pi by 2. Clear? And this point is pi, and so on. I am not drawing it here properly, and this is just for the sake of understanding. This is the graph of sine x, and this is the range of sine x function is plus 1 to minus 1. Okay, so here we have to find the equation of tangent to the curve y is equal to sine x at x equal to pi by 2. Now what we will do, we will differentiate the equation of the curve. The equation of the curve is y is equal to sine x. So the slope is m is dy over dx. Now the derivative of sine is cos x. So at this is the point at which we have to find the tangent. So the value of m at x is equal to pi by 2 is cos of pi by 2, and it is equal to 0. Clear? So the slope is 0. Now what we have discussed just now, the equation of tangent. The equation of tangent is y minus y1 over x minus x1 is equal to m. Clear? Now what is x1 y1? So x1 is this point, this is x1, and what is y1? So y1 is obtained by substituting this value, that is sine x1 is pi by 2, so we have sine pi by 2, that is sine pi by 2 is 1. Clear? So sine 90 is 1. So what is the equation of tangent? The equation of tangent is y minus y1. y1 is 1 and x minus x1. x1 is pi by 2, which is equal to 0. Clear? M is 0 here. So we multiply it here. So we get y minus 1 is equal to 0. So y is equal to 1. So here's y is equal to 1 is the equation of tangent to this curve y is equal to sine x at x is equal to pi by 2, and the tangent line is drawn like this. See, this is the tangent, this is the tangent. Clear? And this line y is equal to 1 is parallel to x-axis. Why? Because the slope is 0, and if the slope of a line is 0, then the line is said to be parallel to x-axis. Clear? So this is a very conceptual problem, and here we can also find out the equation of normal. This is the tangent. Clear? So this is tangent line. Now let us take another problem. Now here we have the problem, find the equation of the tangent to the curve y equal to x cube minus 2x plus 7 at 1 comma 6. So what we'll do, we'll first find the slope. The slope is dy by dx, so we'll differentiate it. The derivative of x cube is 3x square, and here the derivative of 2x is 2. Clear? And the slope at 1 comma 6 is 3. 1 square will substitute x is equal to 1. Clear? So 2, this is 3 minus 2, this is equal to 1. Clear? Now the equation of tangent at 1 comma 6 is given by y minus y1 over x minus x1 is equal to m. So we will substitute the values. Y minus y1 is this is x1 comma y1. Clear? So y1 is 6 and x1 is 1, and the slope is 1 here. So we will simplify it. Y minus 6 is equal to x minus 1, and y is x minus 1 plus 6. So y is equal to x plus 5. So this is the equation of the tangent line. And suppose if we have to find the equation of normal, then this equation will be written like this: y minus y1 over x minus x1 is equal to minus 1 over m. And what is the value of m? M is 1. So we have y minus 6 over x minus 1 is equal to minus 1 over 1. And if we simplify it, we'll get minus x plus 1. So this is x plus y is equal to 1 plus 6, that is 7. So this is the equation of normal. This is the equation of normal, and this is the equation of tangent. Clear? Now we are taking this question, find the equation of tangent and normal at a upon m square comma 2a by m to the curve this. Now this curve is known as parabola. Clear? This is the equation of standard equation of parabola whose axis is x-axis. Now to find the equation of tangent and normal, what we will do, we'll differentiate both sides to get the slope. So y square is equal to 4ax. Now we'll differentiate both sides. We get 2y dy by dx. Differentiating both sides, we get 4a. The derivative of x is 1. So dy by dx is equal to 4a over 2y, that is 2a by y. Now this is the given point, that is, this is x1 and this is y1. Clear? So the slope is, this is the slope. So the slope at this point, that is at x1 comma y1, is 2a over, what is y? Y is 2a by m, and this m is different from this m. So let us say that this the slope is m prime. So 2a get cancelled and we have m. Clear? Now the slope of the tangent to the parabola has slope m. Clear? Where this m comes from this coordinate. Clear? Now the equation of tangent is given by y minus y1 over x minus x1 is equal to m. So we'll substitute the values. So we have here we have say y minus y1. y1 is 2a by m divided by x minus a by m square is equal to the slope m. Clear? Now we'll simplify it, and we have my minus 2a over x m square minus a, and this m and this m, one power will get cancelled, and we have m is equal to m. Clear? Now we'll simplify it, and we have here I am writing it my minus 2a is equal to this m and this m get cancelled, and we have xm square minus a. Clear? Now we'll rearrange it. So we'll get m square x minus my, and we'll take this minus 2a to this side, so plus 2a, and it will give plus a equal to 0. So this is the required equation of tangent. Clear? This is the equation of tangent. Clear? Now let us find the equation of normal. Clear? So I'll rub it, and here we have this. So the equation of normal will be given by y minus y1 over x minus x1 and the reciprocal negative of the reciprocal of the slope of the tangent. So we have minus 1 over m. Clear? Now here it should be m dash or m prime. So we have y minus y1 is 2a over m, and this is x minus x1 is a over m square is equal to minus 1 over m prime. M prime is m. Clear? Now we'll simplify this expression, and we get my minus 2a over xm square minus a by taking LCM, and we have m here and minus 1 over m. Clear? Now this m is multiplied with this m, we will have m square, then m square will be multiplied to these two terms. So we will have m cube y minus 2a m square equal to minus m square x plus a. Clear? So we'll take this m minus m square x to this side, so we have m square x, and this a to this side, so we have minus 2am square minus a is equal to 0. So we have the equation m square x plus m cube y minus 2am square minus a. So this is the required equation of the normal. Clear? This is the normal. Clear? So viewers, now I am taking some problems on tangents and normals which involves some different concepts. Clear? So in these questions we are not going to find directly the equation of tangent or normal, but we are given some other conditions. Clear? So utilizing those conditions we have to find some other parameters. So let us take this question. Here we have find the point on the curve. This is the curve, equation of curve, at which the tangent is parallel to x-axis. So here what we are given, the tangent is parallel to x-axis. Clear? So we know that from coordinate geometry that if the tangent is parallel to x-axis, the slope must be 0. The slope must be 0, or m is 0. That is, the derivative must be 0. So what we will do here, we will differentiate this equation. So what is dy over dx? So dy over dx is, this is 4x minus 6, because the derivative of x square is 2x, so this is 4x, and the derivative of x is 1, so we have 4x minus 6, and it should be equal to 0 because tangent is parallel to x-axis. Clear? So 4x is equal to 6, and we have x is equal to 6 over 4 and 3 by 2. So the x coordinate of that point at which the tangent is parallel to x-axis is 3 by 2. Clear? Obviously this is the equation of a parabola. Clear? So here we have x is equal to 3 by 2. So we'll substitute this value in this equation. So therefore we have y is equal to 2 times 3 by 2 whole square minus 6 multiplied 3 by 2 minus 4. So we have 2, 9 by 4 minus 18 by 2 minus 4. So we have 9 by 2 minus 18 by 2 minus 4, and we have minus 9 by 2 minus 4, and this is equal to 2 4s are 8 and minus 17 by 2. So therefore the required point is 3 by 2 comma minus 7 by 2. So this is the point where the tangent is parallel to x-axis. Clear? So viewers, let us take one more example. Clear? So viewers, now I am taking another problem. At what points on the curve x square plus y square minus 2x minus 4y plus 1 equal to 0 is the tangent parallel to the y-axis? Viewers, in the previous example we have seen that the tangent was parallel to x-axis, and the slope of the tangent was taken to be 0. But here the tangent is parallel to y-axis. Clear? So what we will do here, so the slope of this tangent is not defined, or we can take the slope to be infinity. Clear? Now the slope is the first derivative of y with respect to x. So let us first find the derivative dy by dx from this equation. So we'll differentiate this equation. So what we will get? We'll get 2x plus 2y, and then we have by chain rule dy by dx minus 2 and minus 4 dy by dx plus 0 equal to 0. The derivative of 1 is 0. So viewers, let us divide this equation by 2. So what we will have, x plus y, and we'll collect these two terms, y minus 2 dy by dx, and we have here minus 1 is equal to 0. So in all, dy over dx is given by 1 minus x over y minus 2. Clear? So this is the derivative of y with respect to x, and the slope is infinite. The slope is infinite. So what we will do, because the tangent is parallel to y-axis. So what does it mean? It means that y minus 2 must be equal to 0. So this term should be equal to 0. So y is equal to 2. Clear? Now we have obtained the y coordinate of that point at which the tangent is parallel to y-axis. So we'll substitute this y equal to 2 in this equation to get the value of x. So let us substitute here. So what we will get, 2 square plus y, here we have to substitute the value of y. Okay, so I am rubbing it here. We'll rub it. Okay, so we have we'll substitute y is equal to 2 here. So x square plus 2 square minus 2x minus 4 into 2 plus 1 equal to 0. So here we have x square plus 4 minus 2x minus 8 plus 1 is equal to 0. So x square minus 2x, 4 plus 1, 5 minus 3 equal to 0. So we have got a quadratic expression or quadratic equation here. So we'll solve it by splitting the middle term. We have minus 3x plus x. Clear? And minus 3 equal to 0. So we have x minus 3 plus 1 x minus 3 equal to 0. So we have x minus 3, we'll take common, x plus 1 is equal to 0. So x is equal to 3 and minus 1. Clear? So therefore the required points are, we have the required points as 3, 2 and 3, 2 and minus 1, 2. Clear? So these are the two required points. Clear? Viewers, let us take another problem, and now I am taking a problem which is based on parametric differentiation. Clear? Here we have the problem, find the equation of the tangent at t equal to pi by 4. Here t is the parameter. Clear? And for the curve x equal to sine 3t and y is equal to cos 2t. So viewers, I have already uploaded a video on parametric differentiation. Now let us solve this problem. Here t is called the parameter, and we have the parametric equations, x equal to sine 3t and y is equal to cos 2t. So let us first find the slope of the tangent. Clear? So m is dy over dx, and the dy over dx can be calculated by this expression. We have already studied about it in parametric differentiation, dy by dt over dx by dt. Clear? So let us first find what is dy by dt. So here we have y is equal to cos 2t. So dy by dt is minus 2 sine 2t. Clear? This is minus 2 sine 2t. The derivative of cos 2t is minus 2 sine 2t. And dx by dt is 3 cos 3t. Clear? Now we'll find the slope m at this point. So t is pi by it is pi by 4. So we'll substitute here minus 2 sine 2 times of pi by this is pi by 4 divided by 3 cos 3 pi by 4. Clear? So we have minus 2, this is sine pi by 2, and sine pi by 2 is 1. Clear? And 3 cos 3 pi by 4. Clear? Now the value of sine pi by 2 is 1, so this is minus 2 into 1 and 3 multiplied. The value of cos 3 pi by 4 is minus 1 over root 2. Clear? So we'll simplify this. This minus and minus get cancelled, and we have 2 root 2 over 3. Clear? Now the coordinates x1 comma y1 can be calculated by substituting the value of t in these two parametric equations. So here we have this is x1 is sine 3t1, that is sine of 3t, t is pi by 4, comma cos of 2 times of pi by 4. Clear? So here we have the value of sine 3 pi by 4. So the value of sine 3 pi by 4 is 1 over root 2, and cos, this is cos pi by 2, and the cos pi by 2 is 0. Clear? So therefore the equation of tangent at this point, that is 1 over root 2 comma 0, is given by, now we'll okay. So the equation of tangent at this is y minus y1 over x minus x1 is equal to the slope. And what is the slope of the tangent? We have y minus y1. y1 is 0, and we have x minus x1. x1 is 1 over root 2. And the slope which we have calculated is 2 root 3 over 3. Clear? Sorry, here we have root 2. So we have 2 square root of 2, 2 multiplied root 2 over 3. Now we will simplify this expression here. So we have y over x root 2 minus 1, and here we will have root 2 is equal to 2 root 2 over 3. Clear? Now the value of this expression is, now we have this root 2 and root 2 get cancelled, and we have 3y minus 3y equal to 2x root 2 and minus 2. Clear? So this becomes 2x root 2 minus 3y minus 2 is equal to 0. So this is the required equation of tangent. Clear? Now if we want to find the equation of the normal, then what we will do, we'll apply this formula: y minus y1 over x minus x1 is equal to minus 1 over m. And what is m? M is 2 root 2 by 3. So we can write y minus y1 is here 0 divided by x minus 1 over root 2 equal to minus 1 over m is the reciprocal of this slope. So this is minus 3 over 2 root 2, and by simplifying it we get the equation of normal. Clear? So let us do it. So we have y root 2 multiplied, this is x root 2 minus 1, and this root 2 will go to the denominator, y root 2, and here we have minus 3 over 2 root 2. Now cross multiplying it, here we have 2 to the 4y, 4y equal to minus 3 x root 2 plus 3. So whereas we have 3x root 2 plus 4y is equal to 3. So this is the required equation of normal. Clear? So let us take another problem. Viewers, let us take another interesting problem. Here we have to show that the curves x equal to y square and xy equal to k cut at right angles if 8k square equal to 1. Now here this is the equation of parabola and this is the equation of hyperbola. Clear? Now here what we have to do, suppose the parabola is, say this is the parabola, clear, and this is the hyperbola, say let us first take the tangent to this curve, clear, and suppose, so here we have, say this is the parabola and this is the hyperbola, clear. Now this is the curve x equal to y square and this is the curve xy equal to k. Now these two curves are said to cut at right angles if the tangent at this point of intersection, point P is the point of intersection, and this the tangents T1 and T2, if the tangents T1 and T2 at this point P are at right angles, it means this angle is pi by 2 if 8k square is equal to 1. So what we will have to do, we'll first find the slope of this tangent T1, then we'll find the slope of tangent T2, and if these two, the tangents are at right angles, then the product of their slopes must give minus 1. Clear? So here we will apply this condition. Clear? So let us find m1 and m2. So here this curve, from this curve we'll get m1, and from this curve we'll get m1. Clear? From here we'll get m1. Now we have the equation x equal to y square. So let us differentiate both sides. So we'll get 1 2y dy over dx. Clear? So dy over dx is equal to 1 over 2y. Now suppose the coordinates of this point P are, say, x1 comma y1. Clear? So m1 at x1 comma y1 is equal to 1 over 2 y1. Clear? Now let us find m2. So we'll differentiate this equation. So differentiating this equation both sides, we get here we'll apply the product rule. So first function derivative of second function plus second function derivative of first. So x is the derivative of x is 1 and the constant derivative of constant k is 0. So we have x dy over dx equal to minus y. So we have dy over dx, which is equal to m2 is equal to minus y over x. So m2 at x1 y1 is equal to minus y1 over x1. Clear? So we have obtained the slopes of tangent t1 as m1 equal to 1 over 2y1 and the slope of this tangent t2 as minus y1 over x1. Now we'll apply this result. So m1 multiplied m2 gives minus 1. So we have m1 1 over 2y1 multiplied minus here we have minus y1 over x1 is equal to minus 1. Clear? So here we have my y1 and y1 get cancelled, minus minus get cancelled, and we are left with 1 is equal to 2x1 and x1 is equal to half. Clear? So we have got x1 is equal to half. Now since these two curves cut at this point P, so we can obtain the value of y1 from any of these two equations. So let us substitute x1 is equal to half in x is equal to y square. So here we'll substitute x1 and y1. So we'll have x1 is equal to y1 square. Clear? So x1 is half. So I am writing it here. So this is half is equal to y1 square. So y1 is equal to 1 over root 2. Clear? So therefore the point of intersection P, the point of intersection P is or it has the coordinates half and 1 over root 2. Clear? Now we substitute the value of x1 and y1 in equation 2. Clear? xy is equal to k. So here we'll substitute. So we'll have x1 multiplied y1 is equal to k. What is x1? x1 is half, y1 is 1 over root 2, that is equal to k. Now we will take the square of both sides. So we'll have 1 over 2 root 2 square is equal to k square, and 1 over 2 root 2 square is 1 over 8, and it is equal to k square. So 1 is equal to multiplying k square with 8, we have 1 is equal to 8k square. So this is the required result. Clear? So here we have seen that if two curves cut at right angles, what does this mean? It means that the tangents to the two curves must be at right angles if the two curves are intersecting orthogonally. Clear? Then the two tangents must be perpendicular, or the angle between the two tangents must be 90 degree. And when this happens, the product of the slopes of the two tangents must be equal to minus 1, and the rest of the process is shown here. Clear? So let us take another question. So viewers, let us take this question. Find the point on the curve. Here the equation of the curve is y equal to x cube minus 11x plus 5, at which the equation of tangent is y is equal to x minus 11. So here the equation of tangent is given, and we have to find the point at which the equation of tangent is y is equal to x minus 11. So what we will do? we'll differentiate this function y is equal to x cube minus 11x plus 5. Now let us differentiate it. So what we'll get? The slope of the tangent, m is equal to dy over dx, and it is 3x square minus 11, because the derivative of x cube is 3x square and the derivative of x is 1, so it is minus 11 multiplied 1, that is minus 11, and the derivative of 5 is 0. So this is the slope, m is equal to 3x square minus 11. Now the equation of tangent is given by this equation. So if we compare this equation with y is equal to mx plus c, then we conclude that the slope of this tangent is 1. So m is equal to 1. And from the equation of the curve, when we have differentiated both sides, we get the slope as 3x square minus 11. So this slope and this slope must be equal. Clear? For some point p x1 comma y1. So therefore we write 3x1 square minus 11 is equal to 1. Clear? So this is 3x1 square is equal to 1 plus 11, that is 12. So x1 square is 12 divided by 3, that is 4, or x1 is equal to plus minus 2. Clear? So viewers, here we have obtained the x coordinate of that point. So the corresponding or the y coordinate can be obtained by substituting this value in this equation. Clear? So we'll substitute x1 when x1 is 2, y1 is 2 cube minus 11 2s are plus 5, this is 8 minus 22 plus 5, this is 13 minus this is minus 9. Clear? And when x1 is equal to minus 2, then we have y1 is equal to minus 2 cube minus 11 multiplied minus 2 and plus 5. So we have here minus 8, this is plus 22 plus 5. So we have, I am writing it here, so y1 is 22 plus 5 27 minus 8, that is 19. Clear? So the required points, find the point on the curve. So the required points are 2 comma minus 9 and minus 2 comma 19. Clear? So these are the required points. Now we note the important point here that these two we have obtained these 2 points, and we see that 2 minus 9 and minus 2 comma 19 are the 2 points at which the equation of tangent to this curve is this. So here we note one thing, that this point satisfies this equation as well as this equation. How? Let us verify it. So here x is 2 and y is minus 9, so minus 9 is equal to x is 2, so 2 minus 11, that is minus 9. So this point satisfies this equation. Clear? But this point does not satisfy this equation. How? We can check it. Y is 19, so we have 19 is equal to minus 2 minus 11. and it is minus 13. Clear? And 19 is not equal to minus 13. So this does not satisfy this equation. So our final answer is the only point is 2 comma minus 9. Clear? Now we have the problem, find the equation of normal to the curve y square is equal to 4ax at 80 square comma 280. So here we have to find the equation of normal. So what we will do, we'll differentiate this equation to get the slope of this normal. Now here in this example we'll find both the equation of tangent and normal. So let us differentiate it. So we have 2y dy over dx is equal to 4a. Clear? Now dy over dx is equal to 4a over 2y. Clear? So we have this is equal to 2a by y. Now this is the slope of the tangent. Now this is x1, this is y1. Clear? So the slope at x1 comma y1 is 2a over y1. This is equal to 2a divided by y1. y1 is 2a t. So 2a get cancelled and we have 1 over t. Clear? Now this is the slope of the tangent. Clear? We denote it by mt. Now the slope of the normal is the reciprocal, negative of the reciprocal of the slope of tangent. So we have minus 1 over t. So this is equal to minus t. Clear? Now the equation of tangent can be obtained by this equation. Y minus y1 divided by x minus x1 is equal to slope of tangent. So we have y minus y1. What is y1? y1 is 280 and x minus x1. x1 is 80 square equal to the slope of the tangent is 1 over t. Clear? So here we'll have we'll cross multiply here. We'll get ty minus 280 square and equal to x minus 80 square. So we have ty minus x, and we'll take minus 80 square here to the left hand side. So we have minus 80 square equal to 0. So this is the required equation of tangent. Clear? This is the tangent. Okay. Now in order to obtain the equation of normal, what we will do, we'll apply the equation, we'll apply this equation. We have y minus y1 over x minus x1 is equal to the slope of the normal. So we have y minus y1 is 280 over x minus 80 square is equal to the slope of normal is minus t. Clear? So we have y minus 280 is equal to minus tx, and minus this is plus 80 cube. Clear? Now we can write it here. This is y minus 280 minus tx. So we have tx plus y minus 280 minus 80 cube is equal to 0. We'll take these two terms to the left hand side. So we have this equation. So viewers, this is the equation of the normal. Clear? Here we have to note one thing, that is, this is the equation of the parabola. This is the well-known parabola. This is the parabola, and x equal to 80 square, x is equal to 80 square, and y is equal to 280 are the parametric equation of this parabola. Clear? So here's, let us take one more problem which is related to parametric equations. So here we have to find the equations of the tangent and normal at the point t on the curve x equal to a sine cube t and y is equal to b cos cube t. So here we'll find the derivative by using parametric differentiation. So dy over dx is given by dy over dt divided by dx over dt. So dy over dt is will differentiate this y with respect to t. So we'll have minus 3b cos square t, and the derivative of cos t is sin t, that is minus sin t, and we have already taken this negative sign here. So this is sine of t. Clear? Now for dx dt we have 3a sine square t, and the derivative of sine is cos of t. Clear? So here we have 3 and 3 get cancelled, and cos t get cancelled, and we are left with only 1 cos t, and in the denominator we have only 1 sin t. Clear? So this is the slope of the tangent. Clear? Minus b cos t over a sin t. Similarly, the slope of the normal is the negative of 1 over mt. So which can be written as a over b, and this is sin t over cos t. Clear? Now we have to find the equation of the tangent and normal. So equation of tangent can be obtained by y minus y1 over x minus x1 is equal to slope of the tangent. So we have y minus y1, and here we have y1 is because t is the general point and t is known as the parameter. So y minus y1, for y1 we'll write b cos cube t over x minus x1 is written as a sine cube t. Clear? Equal to the slope of the tangent is minus b cos t over a sine t. Clear? And now we can simplify this expression, and we can get the equation of tangent as, if we simplify it, we'll get ay sin t plus bx cos t is equal to ab sin t cos t. We'll get this. I leave you. I leave you for the practice here. This can be taken as a practice question. Ay sin t plus bx cos t equal to ab sin t cos t. Now this can be further written as x over a sin t, x over a sin t plus y over b cos t equal to 1. Okay, so this is left as an exercise for you. So the equation of the tangent is ay sin t plus bx cos t equal to ab sin t cos t, or this can be simplified as x over a sin t plus y over b cos t equal to 1. Okay, now let us find the equation for normal. Okay, so we have here we have okay, so the equation of normal is y minus y1 over x minus x1 is equal to minus 1 over mt, or we can write it as mn. Clear? So this is y minus y1. y1 is b cos cube t equal divided by x minus a sin cube t equal to the slope of the normal is a sin t over b cos t. Clear? Now we cross multiply, so we'll have by cos t minus b square cos 4t is equal to ax sin t will multiply b cos t with this term and a sin t with this term. So ax sin t minus a square sin 4t. Clear? Now again I am leaving this expression for you as an exercise, and when we rearrange all these terms, we'll get the equation of normal as ax sin t minus by cos t equal to we have a square sin 4t minus b square cos 4t. Clear? So this is the required equation of normal. Clear? So viewers, in today's lecture we have discussed in detail regarding tangents and normal, and in our next lectures we will discuss some more applications of derivatives, and I have uploaded many videos on different concepts of mathematics, so keep watching my videos on those concepts of mathematics, and till then, goodbye.